Now next we will first finish all the components related to this ATmega328. Just move the name to the bottom, go to datasheet, and now we will place the crystal across this crystal pins. Go to place part, type the crystal, double click it and place it here. Next, place the resistor. Place it here. Escape. Next, ceramic capacitor. Select this non-polar. Double click it and place it here. Now this resistor is 1 mega ohm. Just type the value here. We will use the crystal of 16 megahertz. And these capacitors are 22 nanofarad. This one is also 22 nanofarad. Now move the names. Now connect these pins, go to wire. Next we will place the ground symbol here. Just go to this power connector here. Select the ground in the Capsium library, click OK and place it here. Right click and end mode, or you can press escape from your keyboard. Now go to your datasheet and next we will place the capacitor across these VCC pin. So we will also place one ferrite bead in order to stabilize this circuit. But in this schematic they only placed a 100 nanofarad capacitor, but we will also place a ferrite bead in order to stabilize this circuit. Just go to the OrCAD capture, place this non-polar capacitor, escape, and next search for the bead. This is the symbol for ferrite bead and we will place it here. So this is 100 nanofarad. And we will use the ferrite bead for this. So we will type the name after when we search the component from DigiKey. So for now I will leave it as it is. Now copy the component, paste it for analog VCC also. Now go to wire, connect all these pins together. Now you can copy this ground symbol and paste it here. Now go to place power and select the VCC from Capsium library. Place it here. Change the name to 5 volt. Now copy and paste it here also. Now these are the decoupling capacitor, and these capacitors should be placed near to this microcontroller in PCB layout. Now go to your data sheet. Now if I talk about this A reference pin, so A reference pin is connected to this connector, and 100 nanofarad capacitor is also connected. Now we will place the 100 nanofarad capacitor here to this A reference pin. Go to place part, search for capacitor. Change the name to 100 nanofarad. Next we will copy the ground symbol and we will paste it here, and we will also place the ground symbol here too. Now go to wire and connect all these components. Now go to your data sheet, and next we will place the reset circuitry around this microcontroller. Now go to place part, search for diode. We will use the Schottky diode. Search for this Schottky diode, double click it and place it here. Next we will place the resistor to pull up this pin. Next we need a switch, so we will use the SW double pole single throw. Now we also need a 100 nanofarad debouncing capacitor. Just search for cap NP. Change the value to 10 kilo ohm. Now we will change the name of this Schottky diode when we set the part from DigiKey. Next switch is OK. And this is 100 nanofarad capacitor. Next we need a 5V power symbol. Just copy from here and paste it here. Next go to wire and connect this. First the pull-up resistor, and connect this Schottky diode parallel to this pull-up resistor. Now connect to 5V. Now we will connect this circuitry with this push button. First move the circuitry a little bit up here. And this capacitor we will place parallel to the switch here. Select the capacitor, rotate it. Connect this point to this pin here, and we will place a ground symbol here. Just copy the ground symbol and paste it here. Now this is our reset circuitry, and you can easily understand how this works.